Right, so welcome to lesson 2 of the Using Resources unit of work from your GCSE Combined Science course. This is chemistry, and lesson 2 is all about the treatment of water because obviously, as you remember from lesson 1, we spoke about the fact that there are different types of resources that we find on planet Earth. Obviously, we've got finite resources, we've got renewable resources, and we use them for different things. And one of the most important resources that we use is a natural renewable resource is water. And so what we need to consider and have a look at today is how we go about using the different types of water, how we obtain water, and how we make it safe for us to use in different processes, but also most importantly to use to drink as well. So the first thing I want to just start with is defining three key terms. Okay? Pure water, 2, potable water, and 3, salty water. So hopefully, as with our previous lesson in this unit, you've got yourself a pen, you've got yourself paper, and what I'd like you to do is obviously work with me through this video, build up your own set of revision notes going from what we draw here and what we discuss here, and then you can use those subsequently in your own time to be sort of having to go out some additional questions and challenging yourself on them. That if this is set for you as obviously part of remote learning, that'll be sent to you by your teacher. But importantly, for the sake of using this video, pen, pencil, paper, and you're building up your own revision notes as we talk through these key ideas. So, pure water, what is it? Let's define these three things. It's just water molecules. So it's water that is just made up of water molecules and nothing else. So H and 2 O's, lots of them, H2O. Okay, potable water is what we might describe as drinkable water. So often water is treated to make it drinkable. Now, it contains water, low levels of salt, and sometimes safe levels of microbes. And then obviously salty water is the ocean, and it obviously contains water molecules, but it contains high levels of salt and microbes. High levels of salt and microbes. So, with that in mind, obviously, let's think about water as a base resource. And we know that obviously our largest body of water on the planet is the ocean. So if we just draw out ourselves a little Earth here. Countries. Now, 97% of water is ocean water. Okay? It's an important point that we'll make a note of it. 97% of water is the ocean. Whereas we've obviously got 3% locked up in fresh water. The question is, how do we obtain water from both of these and obviously make it useful for us to use and to drink? So the first thing to bear in mind, as we've spoken about already, is ocean water by itself contains too much salt. By itself, it's not safe to drink. By itself, it's not safe to drink. But obviously, one of the main ways in which we go about obtaining water is through process of desalination. So, desalination. Now, main thing we need to do for desalination is obviously removal of salt from water. Now, in terms of a process, relatively simple. If we were to take something like seawater and we heat it, what that water is automatically going to do is going to evaporate. But because water has a different boiling point to salt, um, water evaporates and yet the salt remains in liquid and solid state, whereas the water turns into gas, and therefore it can be separated from the salt and condensed back into pure water. Which contains no dissolved salts. Now, the basis of this is the basis of the process of distillation, separating by boiling points. Now, carrying out process of desalination has benefits and it also has problems. Now, it's of a particular benefit. It's a particular benefit to hot, dry countries. They can use it to obtain water where they might not have readily available water. Now, it's especially a benefit to countries such as this that have lots of oil, because obviously to generate heat, you have to burn fuel, and oil is obviously readily available. And also, if you've got a hot, dry country, there's lots of oil that's also near the sea. That's just in case you want a little diagram. Near the sea, it means it's got a readily available supply of salt water as well. Now, where sort of it can be problematic, not as simple, is that it obviously requires lots of energy. The whole process requires lots of energy. Now, burn fuels can be expensive. Generating energy can be expensive. And additionally, obviously, if you're burning something like oil, you're carrying out combustion. and it can produce pollutants such as CO2, other air pollutants. So you've got our main idea is in what we want to try and do with the available water we have on planet Earth in order to make it suitable for us to use. There are three types of water. The other thing we need to consider is a little bit more about how, more in-depth stages of how water is treated in order to obviously make it safe. Alright? So if you made a copy of your own notes here, turn onto a new page. And we're going to go over the steps involved in the treatment of water. Now, what I would suggest is that at this point, if you're watching this on the YouTube channel, you'll see that there are some YouTube videos underneath that link you to the water treatment process. So I suggest you probably pause the video and go and have a watch of those videos first before making notes and following explanations, just to give you a little bit more context to some of the diagrams and some of the ideas that we're going to discuss here following a few minutes. So if you do that now, then come back to and unpause this video, you should get even more context on what I'm about to talk about. Right. Hopefully you've done that. So if we have a little look at water treatment process. Okay, so it might be worth making a little note at the top here. This is the water treatment process. Now, you've got water that comes from a couple of different places. You've got water that comes from surface and groundwater. So reservoirs either on the surface or natural reservoirs that form underground. Now, these obviously contain lots of microbes, dirt, sediments, twigs, things like that. In order to treat water to make it available and ready for us to use and drink in our homes and our houses, it has to go through a variety of different steps. So, first step it has to go through is you have to obtain it from where they're primarily stored in a reservoir. Okay. Once it's obviously been imported from the reservoir, taken out, goes through flotation pipes. Now, in these pipes, you find large metal grids. Just one here to represent this. Now, these large metal screens or grids made up of bars. Okay, screens of metal bars. Now, what these do is these trap twigs and leaves that might be in the water in large sediment. Now, you might see this process part of it described as the coarse filter. Takes out large pieces of dirt and things we don't want in water. Once it's done that, it then reaches what we call the settlement. This is second. Now, what happens here is that all of the sand, soil, and mud settles. So any sand, dirt, soil, mud that's contained within the water settles on the bottom of the tank, which means you've just got the liquid water that can then start to move on to the next stage. Sometimes see this process referred to potentially as sedimentation. Then moves on to another tank, where we have additional sort of cleaning products added to the water. Things like aluminium sulfate and lime are added to help clean out the water of particular microbes and things like that. Now, remaining bits of sort of small particles and dirt and mud sink to the bottom. Small particles of mud and dirt sink. Now, these form described as sludge. This can often be dumped into, taken out and removed and dumped into things like the landfill. Dumped into the landfill as mud. Good. So our next step is what we call fine sort of fine filtration. So water then travels out through pipes into another tank, where you then have grit and sort of fine dirt like sand and gravel removed. Fine filtration removes mud and grit. Fine filtration removes mud and grit. And then we move on to our last couple of stages before water becomes safe and usable. And that is the process of chlorination. So the water is then exposed to several different things. So it's exposed to chlorine, ozone gas, and also UV light. So, called chlorination. and chlorine, ozone, and UV sterilize water and kill harmful microbes. And after that point, you then have water available at appropriate pH for us to use in homes and offices and buildings. There's a water source available for what we need it for. So that is how water is treated, going from dirty water that's collected in reservoirs and things like that through to the water that comes out of our taps and we use in our homes. But as I say, if you want any sort of more additional context to that, do make sure you have a little look at the YouTube videos in the description below, just for further context. Now, there is one other final process that's worth making note of when it comes to the treatment of water, and that is the process of reverse osmosis. So this is an industrial process. Now, it's a process for carrying out desalination, so obviously removing salt from water. Now, just make a little note here. Now, in terms of what reverse osmosis is, we have salt water forced into a tank and against a water permeable membrane. Really high pressure. Now, this membrane only allows water molecules to pass through. Only allows water molecules to pass through, which leaves pure water coming out the other end. Now, thing to bear in mind is that obviously carries out desalination, but has certain disadvantages in that the membranes are very expensive. Membranes are very expensive, and also it has a low efficiency. You produce a lot of wastewater. Large volumes of wastewater for the amount of pure water that you actually produce. So, for example, it can remove up to 35 grams of salt from every 1 kilo of salt water. So, obviously, as well as doing that and requiring to push the water through at high pressure, it requires large amounts of energy. Now remember, osmosis is typically the movement of water from a high to low concentration through a partially permeable membrane. This is the opposite. So it's from a low concentration to a high concentration of water via a membrane also requires lots of energy as well. Good. So, just another process that you can get your head around looking at producing potable drinkable water from salt water as part of desalination. So you've got several different processes there, looking at the production of pure water from salt water and making it available for us to drink and use in our houses. Make sure you've made your own copies of those notes. And as I say, look at the additional YouTube videos that I put in the description below for this video. And if you're doing this as part of your remote learning, don't forget to look out for any additional questions or comprehension exercises that your teacher sends through along with this lesson. Otherwise, thanks for watching.